what I want to do today is start to talk about shaded region style problems. When we're working with shaded region problems, it's again, like we've looked at before, it's a matter of the large area, subtract the small area, try to isolate what you see. So when we get into stuff like this, obviously I'm going to start out real easy with, a donut. Okay. And yes, as we go further along with these things, some of these do get pretty complicated. But if you get the idea of the basics, the rest of it kind of works out rather quickly. So in this example here, what are the two shapes that it's working with?
Circles.
Two circles. So last time I checked, there is a large circle and a small circle. So in order to figure out the area of the shaded region, I'm going to have to find the area of the large circle. And what do I have to subtract?
Minus the small circle.
The small circle. Good. So area of the large circle. Well, area of a circle is just pi r squared. Well, what's the radius of the large circle? 4. So it's 4 squared pi, otherwise known as?
16 pi.
Which is it?
16
All right.
pi.
Area of the small circle it has a radius of 2. And last time I checked, 2 squared was 4. So that means the overall area of the shaded region is pi. Okay. It's not that it's going to be overly complicated. It's the idea that you just have to do some quick subtractions to figure out what shape you're dealing with. Okay. One of the things that I will also tell you that if you get a negative area, you did it wrong. You probably flip-flop the large and the small. There is no such thing as a negative area. So there's that. Okay. Not terrible, right?
No, it's not yet.
Not yet. Not yet.
It's going to make it worse.
Oh, whiskey? Why would I do that?
It's you.
Yes, I am an awful person. I'm a horrible human being.
Actually, you are.
Thanks.
That's when we're going to make it together.
Yeah, right.
Area of
Very
square
bad.
minus area of circle.
That's all it is.
Yay.
All right. So here, when you start thinking about area of your shaded region, you have a square with a circle cut out of it. So in this case, your large shape would be what?
100.
But the square. And then to that, what would you have to subtract? The circle. So this is going to wind up, and this is kind of a good idea to do. Write down what you're doing. Area of a square, subtract the area of a circle. Now, also, it's good practice to do that because it helps to also reinforce your formulas. So a square is just side squared. And you're going to subtract a pi r squared. Well, the side squared's easy. It's 10 by 10. Can I just write 100 to be okay with that?
No.
No.
Yes.
But what's the radius of the circle? 5. Why is it 5? Very good. Everybody see that? The radius is going to be 5 because that diameter is 10. Okay. So then you would subtract 5 squared pi.
So it'd be 31.4 something?
Oh, I don't know what it is yet. Because I would probably just tell you leave it as an exact answer. If I ask you to leave it as an exact answer, that would be legitimate. If I ask you for a decimal equivalent, then I would just take 100 and subtract out whatever 25 pi is.
Which is 50.65. Or 50.
What, the answer?
21.
Oh, centimeters. So depending upon what the instructions say to do, it might say leave it as an exact answer, or it might say round to the nearest 100. Okay? What's that? No, you never overthink. I've never seen you do that. Yes, ma'am. That's what I'm saying. Sometimes it'll say round to nearest hundredth, sometimes it'll say leave as an exact answer. If I say leave as an exact answer, especially when you're dealing with pi, that just means you'll have pi in there. Because obviously I can't combine 125 pi because when you do that, you have to treat it like it's a variable. You can't combine like this. Okay. Does that make sense?
Just like,
But wait,
just like saying, what's 2 plus 2? Hang on a second, take me. That's all we do. It's the form.
yeah.
So, goodness and
Okay. Now,
Wait, if you think about it, it's not that scary. Because you have 2 triangles within that square. So you have a hypotenuse.
okay, so write it out. Figure it out. Get a piece of paper and write it down. There's a lot going on here. Again, this drops you into a lot of prior knowledge. There's a lot of old material right in this one problem. They're giving you a diagonal of a square. Now, the diagonal of a square creates 2 triangles. They create 2 right triangles. More specifically, what style? They're isosceles, yes, bless you, but 45. So you have to remember your ratios of the pattern of the sides of 45, 45, 90. This was one of the first things that we did back in end of January-ish about the special right triangles. Special right triangles don't go away. When you're dealing with 45, 45, 90s, you're right in saying that it is an isosceles right triangle, which means both sides opposite the 45s are always going to be the same. That hypotenuse, though, was the side times what? Remember? Not 2. Square root of 2.
Yes.
So now in this example, across from which side do you know? We know the 90. We know the hypotenuse. So what I have to do then is I have to take, we have our 45, 45, 90, x root 2. I set that equal to 16. Now we did this a ton. This was a one-step algebra problem. You divide 16 by the square root of 2. And you get 8 root 2. The calculator does that rationalization for you. Okay. Yep, that means across from each of these would be 8 root 2. That gives me my side lengths of the square. Okay. Now, if my side lengths of the square are 8 root 2, what's the radius of the circle? 8. The radius of the circle is going to be 8 because that 16 is the diameter. Everybody see that? So you have a radius of 8. So you have a bunch of little things that you have to piece together. When you start breaking it apart, it's not overly complicated. It's just that you have to remember a lot of material. And that's what this last half of the semester, this last month of the semester is. It's generally a boatload of review of everything you've done. So now, what is the large shape here?
Circle.
It's the circle. So we have to do the area of a circle, and we have to subtract them area of a square. Well, circle, pi r squared, square, side squared. We know our radius is how much? 8. So what's 8 squared? 64, good. So the circle will be 64 pi. The other ones will be a little bit more difficult. We know that our sides are 8 root 2 quantity squared. Notice I said quantity squared. Since there's a root there, since there's a root here, you have to put in, oops. This is really annoying.
Can you like shrink it then move?
That's even more wood. So when I type this in, I have to put parentheses around my root to make this work. That's how I have to do that. Because if I don't,
It's 16.
right. You get two different sets. You have to put the, when you're squaring something with this, with a root in it, you have to put it in parentheses in the calculator. Okay. Because remember, squaring something means junk times junk. 8 root 2 times 8 root 2. That's what that does. Okay. You have to be careful. So that means that your square would be 128. So I have 64 pi minus 128 something squared. That would be exact. What is it decimal equivalent then? 7306. Okay. Now, since we have that 45, 45, 90 up there, what was the ratio of the 30, 60, 90? Just in case that shows up again, because so it probably will.
X, and X, square root 3,
Good.
and then 2x.
Good. And once again, this is the whole basis of trigonometry that you will start to see in Algebra 2. I think actually some of the Algebra 2 classes are just starting trigonometry right now.
Whoa.
It's exciting. Okay. This one starts to get a little bit more interesting. What's that? So this one's a little weird. Again, we're trying to find the area of the shaded region. Now, if you start to think about it, I'm only really worrying about
It reminds me of my morning medication.
Tiny
we have a circle. So now, from here, think about what was larger in that space. If I'm looking at it here, what's the large spot? It's a square, and what do you have to subtract? A circle. Do the outer edges even make it, the outer curves even have anything to do with it? Bless you. No, bless you.
They should have not.
But that's the idea. It's forcing you to try to figure out exactly what in the world we're talking about. Okay. So when I go through that, if I would need to find the area of that shaded region, remember the large shape is the square, the small shape is the circle. So we have an area of a square minus the area of a circle. The square is easy. You have side lengths of what? 6s. So the area of that square would be 36. The circle is also easy. You have diameters of 6, which means the radius is 3 pi r. Which means if the radius is 3, what's the area? 9 pi. There's your exact. Multiply them together, you're probably around 8-ish. You're close. 36 minus 9 pi, hit enter.
You're almost.
7.7.
It's close. I said 8-ish.
Yeah,
7.7256.
7.72.
5.
So it'll be 773. 202. Sorry.
That was even
As soon as I saw 773, I just go right in my head.
What?
No, that's 588, shoot 300.
You're Luna.
Is that my closet?
Yeah.
We were just talking about this the other day too, in some class, how they like, with the, it was in health class, how they had.
I don't even know the last number. Sitting the last number.
It's stupid.
I couldn't remember at first, like,
Oh.
when they
And you're right, and that's the whole marketing ploy. Can you create a jingle that you'll never forget? Yes.
And use it as a study strategy.
Christopher, have you seen the commercial where the lady's like talking on the phone? She's like, "It's two," and she goes hugs her husband. It's two, and two for one at Belco. And she's pregnant. She thinks she has. I was like, that was the dumbest commercial I've ever seen. It's
Yeah. Yes. Commercials. What do you ever do?
Watch Netflix.
Yeah, right.
Oh, my goodness.
Nice.
No, it's not. Okay? It is. So, once again, we're going to a shaded region here. Yes, sir.
Say, okay, so if this is a trapezoid, and we learned way back, I think in semester 1 early, maybe this semester, if that halfway point, like in the middle, would that be, because it's the big one minus the small one, right? Wait, no, it's, you take the average of the two, that's one.
Correct.
So that would be 18, so you would get that really easily.
But you don't need it. But you're right. What you're finding is what's called a mid-segment, but you don't need it because in this case here, it, like you said, it is a trapezoid because you've got a set of parallel sides and you know the vertical height. The reason that you know that the vertical height works for both sides is because all three of these are parallel. If one's a right angle, all of them have to be right angle. Okay? That's one of the reasons why they show the parallel. The only other thing is that in order to make it work for what you were saying, we'd have to have the double tick marks over here to show that the other side was bisected. We don't know for certain, but you were on the right track for it, all right? So the large shape here, like Austin said, is a what? It's a trapezoid. So you have the area of a trapezoid, and then you subtract out what?
A semicircle.
The semicircle. Now the area of a semicircle would be how much of a whole circle? Half a circle. So you take out half the area of a circle. Okay? So put it together. Trapezoid. 1/2 the height, sum of the bases. Excuse me.
Well, we need 144.
And then move this over. Oops. Well, actually, I think you kind of have to assume that it was bisected to make this work, don't you? Yeah. I didn't realize that he did that. Yeah. Yeah. All right. So yes, these have to be bisected to make this work, which makes the radius of the circle how much? So it's going to be 1/2 of 4 squared pi. Have to be very careful on how you type this through. Try not to put it all at once. Okay. Take care of your trapezoid first. 1/2. 8 times 36. Okay. 144. Good. Write that down. Order of operations tells you to take care of parentheses, exponents, and then subtract. Parentheses, exponents, multiply, divide, add, subtract, all in that order, going from left to right. Now, you have an exponent you got to take care of first. 9 times out of 10, what you guys will screw up is you'll take half of 4 and square it. We have to take 4 and square it, and then take half of that, because of the way it's written. What's 4 squared? What's half of it? There's your exact answer. Press a couple of buttons on the calculator, and honestly, I'm trying to remember if, I'm being scary there. I'm trying to remember here, if I do 144 minus 8 pi, if it just gives me, that's, oh, it does do the decimal, I wasn't sure. Sometimes it might spit it out as the exact answer again with these calculators, so do you remember what button you have to press for the double arrow? Yeah. Just so you know. Oh, I forgot to look at what it was. 118.89. Or 87. Whatever it was, inches squared in this case. Okay. So again, it's a matter of, is it gonna ask you for an exact answer, or is it gonna ask you for a decimal equivalent? It's all about, oh, I don't know, reading. Go figure, right? Oops.
Using the decimal.
Don't try to draw that.
It's a Lego.
Yeah,
Yeah.
it's a Lego. Very good call. It's a Lego. It looks like one I've stepped on many times.
At least.
Let's write down what's the large shape.
Square.
All right, so the large shape is a square, and how many circles do you have to back out? 4. Okay. So start with that. You know that you have a square, and you have to back out 4 circles. So write down what you're going to do. Area of a square, subtract 4 areas of circles. Okay? From here, it works out pretty cleanly. Area of the square is just side square. You know it's 20 by 20, which makes it how much? 400. Are we okay with that?
Sure.
Now, because what? No, Ross, we were actually saying something. Oh yeah, the marker just messed up a little. So now, what I want you to think of now is that 20 represents how much when you're dealing with circles? It's 2 diameters, exactly. So that 20 represents basically 2 diameters, which makes each diameter 10, which makes the radius
5.
There you go. So you subtract out 4 times 5 squared, and you slap a pi next to it. So you get 400 minus 100 pi.
Which will give you 85.84 if you round it down from 85.4.
So when you start with these things, obviously they look like they're going to be awful. Bless you. But as you start piecemealing it together, going bit by bit, they're not as frightening as you may think. Yes, sir. What are the 2 yellow things as far as the circles concerned? What are those called?
The thing we learned yesterday.
What are those things from yesterday called?
No,
Area
it's 36.
Sectors? Area sectors?
Sectors. Okay. Yes, sir.
This is kind of simple.
Well, hold on.
Think about it. The white.
Awesome. No, I know where you're going with that. Go ahead, finish out. Guys, give them a chance. Okay? Nobody bitches about when you guys say stuff. Go on.
The white part plus the yellow part will give you 180, because that would be the diameter. Or the 80s. If you think of it as 2 semicircles, the white part plus the yellow part, what's in between that line would just be 180.
Right, because
Yeah.
also you just go through vertical angles.
Yeah.
Since whenever you see 2 lines intersect, if you've got 2 sets of congruent angles, they have to be vertical, which means they have to add up to equal 180. If you're only finding the area of the shaded region, well, what's 180 subtract 109? 71. So this one's 71, and this one is 71. Now, if I put those 2 parts together, how many degrees do you get?
142.
So, angle over 360, pi r squared. Put it together. It's 142, 360, 5.2 squared, and slap a pi next to it. There really, it really isn't much that you have to worry about setting through here. Okay? There's not that much. It's the idea that you're using things that you've seen before. You've got vertical angles, which means when you have it within a circle, they become semicircles, which means you've got 180 on both sides. And you just do some quick subtraction. Now, the stuff that you'll see tonight, yeah, it's gonna be a lot of goofy looking shapes, but it's nothing that you haven't done, okay? There really is absolutely nothing that you haven't done with this. I think I had one more on from the book stuff that you had to go through to, with a special triangle. Here, let me pull this one up again. Which one was it? Oh, I'll do this one.
Oh, yeah, one more. Sorry. I know.
Now, you're going to see a lot of ones like this, especially probably when we get into Friday when we start talking more about geometric probability. What we're going to wind up doing here is finding the area of the shaded region, which you kind of have to do two sets of them, because you've got two rings to this circle that are colored in. So if you think of it as two separate problems, it's kind of the easiest way to go about it. Now, each of those tick marks say that they're all 2 inches or whatever it was, 2 feet. Okay. Which makes the large circle has a radius of how much? 8. So if I'm going to find the area of just that outer rim, I have to take the large circle, which has a radius of 8 squared, slot pi to it, and then to that I'm going to subtract everything else inward. Everything else inward has a radius of what? 6. So I'm going to subtract out a 6 squared pi. That gives me my outer ring. You okay with that? So that gets counted. So that's 64 minus 36. Did you get that, please? Yeah. That gives me my outer ring. That's part 1. Now I do the exact same thing with the inner colored ring. The inner colored ring has a radius of 4. Subtract the whole. 16 minus 4 gives me, therefore, the overall area of the shaded region. You put them together and you get how much?
40.
You get 40 pi. So it's not that it's crazy that you have to try and do all these multi-steps here and there to do all of it. You can break this down into something in piecemeal, and it works just the same. Okay? It works just the same. Question on that at all? I think we'll see a lot of these, because eventually we'll be able to figure out what's the probability of landing in this inner circle, what's the probability of landing in the outer circle, and it all stems from just being able to isolate specific areas of each one of the rungs. Exactly. Oh, probability, you're so much fun. Add this to the stuff you guys had last night. Just use these as the pages as themselves. Do all the work on a separate sheet of paper. And let's do this. On this, I'd like you to start on, this is 11.5B. do that. Do you want a separate sheet of paper that we have, you can just add it into the homework you had going on from yesterday, and we'll go from there. All right? So you've got that first one. Oh yeah, do you mind? Thank you. Yeah, that first one you're just using, it's one of those big picture type problems. Just start filling the blanks as you go. So there's 3 parts to that first part. Good times. Oh, shit.
Have you given them?
It was an example, yeah.
I had to give them an
Appreciate
example.
that, thank you.
You see, I didn't. It's like hard food too.
So one day, so